The wooden track layout. Reverse merge. Wooden tracks, electric trains. By Gary Schick. November 2025. In this episode of our series, Wooden Tracks, Electric Trains, we continue our analysis of merged tracks as we explore another application of these components. In part one of the reverse merge, we reviewed terminology and looked at several variations of reversing loop layouts. We also learned that an inverse curve configuration causes a train entering the exit of a reverse merge to exit at the merge track curve entrance, and saw some applications in the reversing loop. We ended part one with a challenge question regarding a configuration with two adjacent merge tracks, where the two merge are connected at the two exits and where the two curve entrances are located on opposite sides of the tracks. In this teaser video clip, you should be able to see several instances of this adjacent merge configuration, and we will be discussing what is occurring in this layout. Since an inverse curve produced by a simple curve causes a reverse merge exit at the curve entrance, can an inverse curve be produced in a preceding forward merge and cause a similar reverse merge exit at the curve entrance? In this video clip, we show a layout with 5 inverse curve merge intersections. There are 2 intersections labeled IC4 and IC5 that are constructed by using a curved track ahead of a merge exit, which is the same type of inverse curve we have previously shown. However, the intersections labeled IC1, IC2, and IC3 that are constructed using 2 adjacent merge tracks that are connected exit to exit. The 2 adjacent merge tracks that are connected at their exits have respective curved paths inverted from each other, so that the adjacent curves of these merge tracks also form an inverse curve. A train entering either merge track at the merge track curved entrance exits the first merge track after a standard merge. Upon exiting the curve from the standard merge, the train enters the second merge track at that merge track exit, causing a subsequent reverse merge. We expect that after arriving from an inverse curve within the preceding forward merge track, a train will exit at the subsequent reverse merge curve path entrance. On the other hand, a train entering at a straight entrance of the preceding forward merge will exit the subsequent reverse merge at the reverse merge straight entrance. A configuration of 2 merges connected exit to exit, where there is an inverse curve in the 2 curved sections, creates a special type of level crossing track. In this special level crossing, a straight path crosses the path of an inverse curve path, which is the same as saying an inverse curve path crosses the path of a straight path. The crossing occurs because of the reverse merge principle that tells us that an incoming straight entrance at the exit causes an exit at the straight entrance, while an incoming inverse curve entrance at the exit results in an exit at the curve entrance. For lack of a better name, we call the configuration of 2 merge tracks connected exit to exit an inverse merge crossing. In this video clip, we see 2 engines traveling counterclockwise loop routes that intersect at an inverse merge crossing. The inverse merge crossing relies on a principle that a straight reverse merge continues straight through the crossing, while an inverse curve reverse merge crosses through the curve path. The red-colored engine travels a loop route that repeatedly enters and exits 2 inverse merge crossings at intersections IC1 and IC2. The red-colored engine enters and exits both inverse merge crossings at curve entrances. The blue-colored engine travels a loop route that repeatedly enters and exits 2 forward merge crossings IC IC4 and IC5, and two inverse merge crossings, IC2 and IC3. At forward merge crossing IC4, the blue engine uses the straight merge entrance, while at forward merge crossing IC5, the blue engine uses the curve entrance. At both inverse merge crossings, IC2 and IC3, the blue engine crosses the intersections after entering and exiting through straight path entrances. The blue engine's straight crossing route at the intersection labeled IC2 crosses the route of the red engine's inverse curve crossing at that same intersection. We can also see the path of the red engine and the path of the blue engine crossing at a 45-degree level crossing component located near the right edge of the layout. Returning to the video clip we showed at the beginning of this episode, we can now look at the layout with the insights we have gained. In this video clip, the train travel path is clockwise, whereas in the previous clip the train travel path was counterclockwise. The path of the red engine in the clockwise travel direction is identical to the path in the counterclockwise travel direction. The red engine is on a symmetric reversible loop route, and the engine direction can be reversed anywhere along the route. However, the blue engine's route is not symmetric, and reversing the direction of travel initiates a different loop route. The blue engine travel can be reversed in the track section between intersections IC4 and ME1, where the clockwise and counterclockwise paths overlap. In the clockwise travel direction, the blue engine enters a reverse merge from the inverse curve at IC4, so the train diverts to the outside track at the left side. Next, after traveling upward along the left edge, the path curves to the right and enters the straight entrance of the inverse merge crossing at intersection IC1. After the straight crossing at IC1, the path bends downward and after a short distance enters the curve entrance of another inverse merge crossing above the intersection IC3. From the curve entrance above intersection IC3, the engine crosses the intersection and exits at the curve entrance below. The subsequent path leads downward through an unlabeled level crossing to a standard forward merge at the intersection labeled ME1. Continuing to the left, from intersection ME1 to intersection IC1, the blue engine completes the loop route. It would be nice if the blue train could have an optional, more symmetric reverse direction route, similar to the reverse direction route available to the red engine. We found a way to upgrade a small section of the blue engine track in the area around intersection IC4 to achieve an optional and more symmetric route variation, while also preserving the existing asymmetric route. Take a moment to visualize how the desired upgrade might be accomplished. We will show you our solution. Here in part 2 of the reverse merge, we defined and analyzed a configuration we call an inverse merge crossing. If you enjoyed part 2, and would like to see how we improve the route of the blue engine, please find part 3 of the reverse merge on the YouTube channel, Wooden Tracks Electric Trains. In reverse merge, part 3, the bypass, we provide another way that merge tracks help to provide solutions in complex layouts. Thanks for watching. We hope you subscribe to the channel, and please click like for each video you watch. The information presented in this video is an honest representation of an actual wooden track layout using battery-operated toy trains. These videos are intended for entertainment and the enjoyment of hobbyists and enthusiasts. The train layout design and construction are our own and are provided without financial incentive. We share these videos on YouTube for our own satisfaction. We welcome constructive and polite feedback.